Okay, so if we want to Laplace transform 1, how do I do that?
Just cram it into
The improper integral.
Cram it in the function. So this should be the integral from 0 to infinity of e to the minus st times, what's the function I'm Laplace transforming? 1.
Uno.
I gotcha.
Okay,
dt.
and then I would have it times 1 dt.
You would
Cool.
have, or you do
That's
have.
pretty easy.
I mean, you do have, right? You would have and you do have. There is a 1 there.
You didn't write it down. Joe, how will we know?
Hey, can you go ahead and pull that one out, please?
Better? Alright, so how do you actually integrate this?
It's improper, so
With
you
a
say
limit.
a.
terms of t. So
Yeah, so you need some tricks, right? It's an improper integral, so you need a limit. And also, what else? And also,
We do like just the subtraction.
how do you
Right.
integrate
There's a
e to the
W
minus?
sub.
You need like a place where.
Yeah, you need a u sub, right?
W sub.
So,
This is like
so you let u be minus st, right? Then du is
that's some
dt.
negative s dt. You don't have a negative s, do you?
No.
No?
You're
It's
one
like
over
no,
negative
factor one
s.
out, you know what I'm
Yeah, it's constant with respect to t, so you can do a minus 1 over s out here, and a minus s in there.
saying? I was
You guys love that?
We were talking about this earlier too.
What?
Fine. Well, we'll get into it on that.
Okay. Alright, so I got minus 1 over s, right?
Integral.
The integral of e,
Oh, you forgot your limit.
yeah, I forgot the bounds. Just
But-
wait for it.
But
E to the what?
U.
You.
U,
It's just negative one over s.
du. And then you're like, wait. What about the bounds? So,
let a
this is a bound in what?
t.
T. So when t is 0, what's u?
Oh no. Is this?
Oh, it's 0. Infinity.
0. And when t is infinity, u is
Negative infinity.
negative s times infinity, which is negative infinity.
Why can't we just leave it in s's and t's and deal with it? Sweet, that looks so much easier.
You can.
Okay.
So this would be minus 1 over s times, let's see, e to the u's integral is e to the u, right? Evaluated from 0 to infinity, or 0 to minus infinity.
Right.
Yes? Which gives you
Negative 1 over s.
negative 1 over s times
1.
The bottom minus the top. Yeah.
Well, you could say 0
Top minus the
plus
bottom.
1.
that's the top minus the bottom still. So that'd be e to the minus infinity minus e to the 0.
Can we just call that? Would that be 0?
Good. E to the minus infinity is 0.
Into the zero.
That's really where you should use a limit, right? Like really you should be calculating the limit as n tends to infinity of e to the minus n.
That's a lot of stuff.
Right, but you guys know how limits work. I'm going to trust you. I'm going to pretend that you know how to do calc too.
He's not even trusting.
That's a
So I think what I have here is minus 1 over s times minus
One.
Nope. You just
1
Yeah.
gives me
1 over s.
that this is 1 over s. You guys with that? And there was a bit of weirdness here. I made an assumption. What was, does anybody, yeah, specifically s isn't 0, and also
Technically not. S is a constant.
s is const, well, s was constant with respect to t, but I made one more assumption. It's right
That it's
here.
continuous.
Blue is the color to use. Oh, and then you just sub back into whatever?
No, what did I assume? When I said, okay, if u is minus st,
Oh.
S is
if I plug in t as infinity,
S is positive.
yeah, I specifically assumed that s was positive.
So why can't we just say plus or minus 1 over
Good, because the integral diverges. Right, if s is negative,
Okay.
you guys see that?
You need it to converge.
Where did you say?
Yeah,
it was?
I need this integral to converge to even talk about this being a function, right? In order for me to get an answer over here, and not just the number positive infinity, right? I need this integral to converge.
Where did you say it was greater than 0? Sorry.
So the reason I said it was greater than 0 is here, right?
Sure.
When I made this substitution, I thought to myself, when t is infinity, u is minus infinity.
Sure.
And that was crucial because that step happened again right here.
Mm-hmm.
Because if this wasn't if this wasn't e to the minus infinity, this thing wouldn't go to 0.
Yeah.
Right? It'd go to infinity.
We're assuming that u is.
So from the step from t is infinity to u is minus infinity
Oh, and s is
relied on me assuming that minus s is actually a negative quantity.
Okay. I got it.
Right? So I forced this.
Cool.
I really just made a naive assumption, like, oh yeah, s is positive, like no problem. But this doesn't work unless s is positive. You see that?
Okay.
So there's two issues. One, s can't be 0 because I'm dividing by it.
Sure.
And 2, s has to be positive because otherwise the integral diverges.
Cool.
You guys good with that? Okay, so this is how you Laplace transform a constant.
What?
If I had a different constant in there, how would this change?
Just by the factor of whatever.
Yeah, so if you were doing Laplace of, oops, that's
Because
not,
constants come out of an integral, therefore
yeah, so if you wanted to do the Laplace transform of pi, right,
pi over s.
Doesn't matter points.
you would get pi over s, and what restriction would there be?
Same.
Same, s has to be positive.
What is it?
Now, what were we to do? Oh,
Yeah, we're gonna combine those or something.
never mind.
Does that make sense?
Yes.
Why is it? Why is it when it's negative it diverges, when it's positive it converges?
So, it's related to this guy right here, right? E to the minus infinity goes to 0, right?
Yeah.
So if I had e to the positive infinity here, right, then it would diverge.
Okay, I thought you were talking about the 1 over s. Is a
Yeah, it's really just that this wouldn't even make sense.
So what do we do if we get to nonsensical?
If you get to nonsensical things, the issue is that there isn't a Laplace transform that's going to work, right?
Okay. So just
You
get
see
up
that?
and go home.
So, yeah, really what's going on there is this arrow that you were trying to take, right? Like I'm trying to walk down Laplace transform to a place that's better.
And back up.
Yeah, there might not be a place that's better.
So
That said, for most reasonable things, the Laplace transform is something that'll converge, it'll be fine.
what would we do then if there was no dE and there was no Laplace transform?
So if you started with a differential equation that you could not Laplace transform, you would try one of the other techniques you have for differential equations. Remember, the one that always works is to write it as a series and force it.
So now we can never get out of it.
Yeah, you can never get out of solving differential equations now because you know how to write it down as a series and try.
I'm gonna try and find an
Supposedly.
exception.
Do we really though?
Yeah.
Yeah, I didn't give you guys a ton of time with that, right? So that's not a like big skill that you have, but it is always the fallback. Like, and it does only transform things into very hard or extremely hard. You won't ever get to easy there, right? So you hope that doesn't happen.
Who gave us a burden?
So questions on this?
No.
No?